Most engineers get this wrong, and this can cause a real foundation failure. Look at this. When some footings are very close to the boundary line, as you can see that, and then most of the footing are now crossing to the property line, as you can see that. Now, this is not allowed in real life, because encroaching your footing into someone else's boundary is not allowed when it comes to construction wise. So now in that case, that gave room for an eccentric column design. But when designing for eccentric column, there are several problems that people encounter, which I'll show you in this video. But here is the real problem for eccentric footing, because even if your software says that everything is okay, as you can see it here, the big issue is that due to the uneven uniform soil that are always found at the base of the footing, you will have an uplift or overturning. And most mistake that people do is to design eccentric footing in a very different way. For example, as you can see on this particular one which you're seeing here, this is what someone designed during the construction, as you can see also the site picture here. Now, this software says it is okay, but based on standard or structural engineering standard, this will fail based on uplift. Now, what this person was trying to achieve was to provide a counter weight around this region. That is why he now added this beam and then this beam and this beam. But what happened is that this whole scenario cannot really counter the overturning effect which is happening around this place. So even if they have done this and the software says it is okay, or they have done this and the software is saying that this is okay, now this is not actually okay, because I always say that whatever you give a software is what the software will give you back. So if you give a wrong structural model that is not supposed to be, the software will design it based on that. And if at site, since what you have in mind is not what you gave the software, and that would be an issue which will make your structure to be practically unsafe. So in this video, I will show you the exact mistake and how to fix this particular problem that engineers encounter using the help of what? A strap beam, as you can see here. So this is the only possible way you can actually counter the effect or design an eccentric footing which is theoretically and practically accepted in engineering world. I will also tell you all the rules and also the guidelines that are involved in designing a strap footing, as you can see here on my screen. Now, even if you are seeing this strap footing which we have just seen now, and you might think, oh, this is perfectly okay, but I am telling you that this is actually not okay because of this. And I will be telling you all the principle involved to design this strap footing or this eccentric footing effectively using this software ProtaStructure. Notwithstanding, we have a course video that we did this strap footing completely for a project, and also the detailing, which you can get on our Eccentric store. Okay, that is fine. So if you need that, you can check the link below this video description and then get that. Okay, that is fine. But just for those that just want a quick understanding of what we are to do on this strap footing, I will still show you how to design a strap footing and the principle. But basically, in everything, it is best if you can afford it, you get the course video, because that is where I explained more in details. Because based on the time duration of this video, I might not be able to explain everything that we will have to touch on strap footing. Okay, that is fine. So here is the situation. We designed a 2-story building, and after our design, and we have also done our drawing and sent to the client. Now, during the construction, we discovered that the architect didn't take into consideration the boundary based on when he was sizing the width and the length of his building. Now, during the setting out, we now discovered that on this grid line A, which you can see here, on this grid line A and grid line 1, these footings were already encroaching into the other property boundary, which is not allowed based on construction and others. And then we advise the client to maybe shorten the width of his building. Understand, that is the only approach, shorten the width and the length. But the client says no, so that is now what gave room to another engineering justification based on foundation design. So we then say, okay, we can still design an eccentric footing having a strap beam. So based on that, we are going to design an eccentric footing that gives room to a strap beam to be able to balance the counterweight or to transfer the load from this footing down to the interior footing. Now, just to give you a clearer view, this was what happened at site. You could see the fence, which is the boundary property line, as you can see here. So most of the footings around this place was already encroaching into the property boundary line, which is on grid line A, as you can see that. And also we also have the same thing happening on this side, which you can also see boldly here. On this place, this is majorly affected, as you can see that. So in this course now, we cannot design a central footing where the column is sitting directly at the center of the footing. So in this case, we need to design an eccentric footing where the column sits at the edge of the footing. So in that case, all the foot that you are seeing here, this footing now is going to shift to flush directly at the column point here, all right? And also these other footings that you are seeing here, we also shift back to flush with this. So when this happens, that gives birth to what? An eccentric footing. And that becomes very, very difficult because now all the weight now will now be on one side, and that will cause what? Overturning on the other side of the footing. And since in that case, when all the loads are at one point, what happens? It will give birth to non-uniform soil pressure at below the footing. And for eccentric footing, this is where it gets dangerous during design, because now all the loads are no longer at the center of the footing. They are now at one edge of the footing. So because the load is no longer at the center, it is now at the edge, this causes the soil pressure to become uneven, and one side carries too much load. As you can see, one side carries too much load, and then the other side of the footing, which you can see here, will now cause an uplift or what? Overturning, because as you can see, there will be an overturning forces here happening here, which will cause this footing to do what? Overturn, to now respond to this weight that is already at one side. So in this video, I'll be showing you how to practically design a strap footing. So sit back and watch that. Now, before we start, this month of April is our Eccentric anniversary month. So if you want to purchase any of our products, this is the right time to purchase that, either to enroll for our Eccentric mentorship training, which this strap footing has also been added to part of our Eccentric mentorship training, because before we have 20 projects that you are going to be trained on. So now currently we have 21 projects currently on our Eccentric mentorship training. If you want to enroll for that, you can go to Google and search for Eccentric mentorship training, or search for Eccentric store, and you can get all our products for 50% discount. Note, this runs for only this month of April and ends on April 30th. So you can also get most of our expensive softwares and all that by using this time frame. Okay, that is fine. Let's now begin and dive into the complete design of this strap footing, and where I will show you all the guidelines. That is fine. If this video looks well for you, and then please give us a thumbs up and also share to other younger engineers that they can also learn how to design a strap footing. Let's now begin on the strap footing design. In the concept of a strap beam design, the load on footing type 1, which is an eccentric footing, is being transferred to the footing base of footing base type 2, as you can see that here. Now let's assume that this is the load, which is P, on footing type 1. Based on this eccentric footing that you are seeing here, there are going to be an overturning moment around this place, because the load is now at or centered at one particular edge and no more at the center. Now, based on this now, you will have to introduce what they call a strap beam. Now, that strap beam now will be acting as a transfer member and not as a foundation beam. It is not going to rest direct or have any contact with the soil, as you can see here that it is being lifted off from the soil. So the only thing that will have direct contact with the soil is just the footings. So only the footings that are going to have direct contact with the soil, and the soil contact on this eccentric footing area must not be triangular, it must be uniform. Else, if it is triangular, what happens is that it's going to cause an overturning around that place on that footing. Now, knowing that it is practically impossible during design to design against or to like design that let the footing that this column at one side, which is an eccentric column, becomes overturning free, because the reason is because when it comes to the E, which is the eccentricity, that the E must be less than B all over 6. Now, in most practical cases, in fact, in most practical structural design cases, this E is always greater than B all over 6. And when E is greater than B all over 6, what happens is that it causes what? Tension. This footing here becomes a tension. And in combined footing design, when a footing is at tension, what happens is that we provide what? A top reinforcement, making it what? A doubly reinforced. But in this case of an eccentric footing, even if you provide like a top reinforcement, it will not be able to counter the counter effect or the what or like the effect that this load is causing an uplift. So what do you then do? It is now the time that you now have to do what? Provide what? A strap beam. So this is a strap beam which takes care of what? The overturning. One, also stabilizes the soil around this footing, under this footing, causing a uniform footing. Okay, then it also transfers the load from this column through this strap footing, which you're seeing this arrow here, onto this footing, this interior footing. So this is the concept of a strap beam. In this video, or in this course video, I'll be showing you in detail how to design a strap footing for a building. Now, we are going to use this two-story building for this particular strap footing design. Okay, that is fine. So watch out. Let's now begin for this design. Now, on this video, you can, when you are faced with that kind of challenges where you have an issue with the boundary property line, where your footing are encroaching into the boundary property line, you can then design your footing as an eccentric footing. Now, before you must do that, you must be sure that you have done all your design. As you can see that you have done your designs and then you have checked everything about your superstructure, which is the normal way before you can now begin with your foundation design. So as you can see on my own case, you can see my design start using everything, and we have also carried out our visual interrogation, that is trying to give our engineering justification for the beam reinforcement and column reinforcement, and giving our own choice based on engineer. So we have done all that. Okay, that is fine. So now we are now entering back into the foundation design, and we are only going to focus on the footings along grid line A and also along grid line 1, because those are the ones that are majorly affected, as you can see, which you can see here correctly. So the grid line 1 and the grid line A are majorly affected, as you can see that. All other ones are not affected, as you can see. So we are only going to focus on the footings along grid line 1 and grid line A for our eccentric footing, all right, which will now give birth to the strap beam or the strap footing design. Okay, that is fine. Let's now dive into our design for that. But first, we are going to model all the footings back on this particular area, and also model for the strap beam. Okay, that is fine, which I'll be showing you the principle of how to model a strap beam, because most engineers make that mistake of modeling strap beam very bad, and the software is going to design it as it is, but the function of the strap beam now becomes useless, which you can see here. In this case, this looks like a strap beam, all right, connected to an eccentric footing, which you can see here. But basically, this strap beam is no longer functioning as a strap beam from the principle of how a strap beam should function. But right now, it is now functioning as a foundation beam, which a strap beam is not a foundation beam, but it is just a transfer member to transfer the load and also to counter the counter the what? Overturning moment, which is happening around the eccentric footing. Okay, that is fine. Let's now move on to the full design of this software, of this building. So in that course now, I will then go back to my normal view interface. Now, once I go to my normal view interface now, the first thing I'll do here is to, since the model is like this, I'm going to highlight all the footings that are having that issue. So for example, these ones are the ones having the issues. Okay, that is fine. So these footings around grid line A, grid line 1, and also along grid line A are the ones having the issue of what that they are encroaching into the boundary property line, as you can see that. So these are the footings here. So with this, I will then come here and do what, delete this. Now note that I am using Prota 2026. All right, now this is where this works perfectly. Now I have deleted all the footings on grid line 1 and also grid line A. Okay, now if I go back to my plan view now, as you can see that, you can see that all our footings on grid line A and grid line 1 are no longer available, because now we want to change the design of all these footings along this line to now be an eccentric footing. Okay, that is fine. Now I am using Prota 2026, as you can see here, and this works perfectly on this version. But in our course video, we outlined everything on how to design strap footing. Even if you have older versions, we have a means to like do that. Okay, so we have for 2022, 2023, 2022, 2024, and 2025, even 2018. We have the course video for that. So if any version you are using, you can go and then get that video based on our course video based on that version. Okay, that is fine. Now we don't use 2021 ProtaStructure version. That is because it has an issue in terms of it has software issue in terms of modeling of foundation and also design of foundation. That's why you hardly see us making a video using that version of what ProtaStructure. I'll advise, if you're using that version, try to move to 2022 or any higher one. Okay, that is fine. So in this video right now, this will be based on 2026 version of this software. Now, knowing that we are going to design an eccentric footing on this, the first thing to do is to model an eccentric footing. Okay, that is fine. Now I'll click on this place now on one of the footings. Okay, right click and then click on what? Click on insert part footing. Okay, that is fine. So when I click on insert part footing now, I'll wait for that to display up. Okay, now when it comes like this now, you can see that on this place that says footing eccentricity, as you can see that footing eccentricity, we have several ways how you can place your footing, either at an edge. Okay, you can see that now you can see that when it was at this place, everything was passing based on the design, but once it comes to an edge, you can see that they are still failing. All right, that is because of what? There is now an overturning moment overturning moment occurring at this place. Okay, at this place, at this side of the footing. Okay, now if you also go and then click also at this side too here, you can also bring your column here. You can also see the same thing, it is failing. Okay, so when now eccentric footing has that issue, can you see that they have the issue, but once it's at the center, everything becomes normal. Okay, but once they move to an edge, then that becomes an issue. Okay, that is fine. Now if you're using an older version, this will be very difficult for you to design, because as you can see, when I'm doing my own here, you can see the only error I'm having here is just the punching check. Okay, that is fine. But for 2026, most things have been corrected based on this eccentric footing design. Okay, as you can see that right now. So but what I want to do is to have my footing to flush directly at the face of this column. So that gives me now the point of using this option here. You can see the best option here. Now you can see that when I've clicked this, the software says design successful. But the question is this really practical? All right, is this really practical? My answer is no. So don't forget that when we started Ekide newly, I always hammer on, don't depend on what the software is given to you. You have to give your own engineering judgment. All right, and we started that based on checking our beams, and we saw that most times the software tends to increase the beam reinforcement size, all right, to 2025. But later you can see that even 16 can be perfectly okay for like that. So basically, this, as you are seeing here, is not actually designed properly, even if it is showing what design successful. So when you're using any software, that's what they always advise, that when using a software, you must have an experience first as a structural engineer, you must know the thumb rule, the guiding principles of what you are designing before you can now switch to software. Software don't just go ahead and you don't just use software because you want to use it. You use software because you want your work to be faster, because you already know the manual principles, the principles involved in designing that which you want to use the software for. Now, it is when you know the principle that it is now authorized for you to go and now use the software to make your work faster. Okay, that is fine. So in this course now, we will then have to I will be showing you the principle on designing this strap, this eccentric footing. Okay, that is fine. Because what is happening here now is that at this point now, as you can see here, at this point, what happens here is that all the loads now is now at this particular point. Let me just come here and then add this. All the load now is now at this particular point here. Sorry, let me just change that. I don't like that. So all the load now is now at this particular point here. Now, when the load happens here like this now, as you can see, what then happens to this other side? Because all the weight now is now on this place, it will cause an uneven soil. Something like this will happen. All right, it will cause an uneven soil. All right, given this place, since the soil under the footing is now uneven, it will make this place to have less soil. So more soil now will be on this place, because here now the load is all on this place, so the whole soil here now becomes uneven. And when this happens, when the soil here becomes uneven, it will cause overturning here or an uplift. Okay, because this particular side of the footing now has lesser soil. Now, when that happens now, what then occurs? What occurs is that it will now cause an overturning, which you will see something like this. It will cause an overturning like this. All right, moment. So when you have an overturning like this now, and also you will also have a different one again going like this, because now it is now trying to do cause uplift. Now, when this happens, what then are you going to do? That is when you will now have to do apply your engineering judgment to do to provide a counterweight or to transfer the force of this like the force on this column here to a different footing. Now, knowing that we already have a column or a footing that is just beside this particular one here, which you can see if I just minimize this now. So since we already have a footing, all right, that is already around this place. So what do? We are going to connect this eccentric footing now to this other footing here, which this column here. Now, this connection now that we are trying to do here is now what we call a strap beam. All right, where this strap beam helps to transfer. There are two things it helps. One, it helps to transfer the load of this column to this other footing. Okay. Two, it also helps to act as a counterweight to this footing that is already occurred, to this eccentric footing that which we are currently having here. Okay, so it will also act as a counterweight to this eccentric footing which we have here. All right, to take care of all the weight that we are experiencing here. Then it will also act to help to do to give a uniform soil around the bottom of this footing. Okay, that is fine. So that now gives us room to now go and now modify or model our footing properly. Okay, that is fine. So let's now go back now to first of all insert our eccentric footing, and then come back now to come and do our proper engineering judgment or engineering design. Okay, that is fine. So I'll come back now, click back on this place here, and then click on this insert footing here. Now, when I insert this footing here now, what will I do? I'll wait for it again to show again. I will then come here and then click on this. Now, note, if you're using an older versions, this will give you an issue. Okay, it will give you an issue, but we have a course video on that which you can get below this video description on how to design that. Okay, that is fine. So then we will then come here, but if you're using 2026, we have a complete video for this building, for just the foundation, not the whole modeling of the structure, just the foundation of the strap, okay, of all the strap footing on this grid line A and this grid line 1. Okay, that is fine. So when you come here now, as you can see here, you can see that everything now is okay, everything here is okay. Then you can see here too. Now, based on this, you can see that E here, which is the eccentricity. Now let us justify this. And how do you calculate this? First, you have to check that b all over 6. If it is if this e is a more than b all over 6. Let us confirm that now. So we are going to confirm if this e eccentricity is what is now is less than b, which is the width of the footing, all over 6. That is the formula to like confirm if the design of your eccentric footing is okay. Then if it is not okay, then that will now give room to now provide a counter structure. Okay, all right, that is fine. So if we now check that now, you see that our b here for this footing is 1400. All right, divided by what 6 equals to, that gives us what 233.3. So let's just say approximately 234 in worst condition, although this can be 233. So you can see that 233 what millimeter. So E now is greater than 233 millimeter and not less than. But the formula is meant to say that our E must be less than or equal to B all over 6. But if it is greater than, then there's a failure. Now, since our E now is greater than B all over 6, which are giving us what 233. Okay, so what is the what does this thing mean? What it means now is that the part of this footing is in tension. All right, the part of this footing now is in tension. Now most things that will come to your mind, okay, yeah, if it's in tension, why not us just provide a double reinforcement, that's a top bar. Now, in the case of combined footing, top reinforcement is always there to do what? Counter the tension force, okay? But in the case of an eccentric footing, providing only top reinforcement cannot justify that, cannot only counter the issue, because the part of the footing being in tension is not only the failure, or is not only the warning that you are experiencing. Now, when this E also is greater than B all over 6, the next thing again that thing means is that the soil contact is not fully, like is not full. So what it means is that the soil contact around this place now is not full, okay? Is not full. Because basically the soil contact on the footing is meant to be full, meant to be what? Uniform. So when it's not uniform, it causes the tilting of the structure. The structure now begins to do what? Begins to tilt, all right, at that place where there is ununiform soil. Okay, that is fine. So in that case now another thing again that this thing causes is, now since the B, which is this B here, let me just use the smaller this. Now since this E here is, since this E is also less than B all over 6, what happens? Like in real engineering, the real pressure is now under the soil is now what? Triangular and no longer uniform. And what does that mean? We now have a triangular soil like this. Okay, we now have a triangular pressure like this, which does not actually make sense. This will cause a failure and also unstable, because basically what we are meant to have, what we are meant to have now is for a good soil, it's like for a good foundation, we are meant to have like a uniform soil like this, where you have your soil pressure, understand, coming like this. This is for a good foundation design. But in this case of eccentric footing, we are now having a different thing. Okay, that is fine. So I will now click on what? Cancel here. So since we have this issue now happening, and we want, this is how we want it to be because of the boundary. If this footing extends further, it will go into the, it will not encroach into the boundary area, which we do not want. So does it mean that we cannot design this again? No, we can still design this. Okay, that's fine. And that is what gave birth to what? To a strap beam or a strap footing. So if we now, since we have another column that is existing within this place, we have a column that is existing within this place that has a footing, okay, that has a footing around this place. So what do? We are now going to connect that using a strap beam. We are going to connect these two using the strap beam to be able to now transfer the load of this column, all right, through this beam to this particular footing. So most times this footing tends to be what? Bigger than this. That's because this footing now is now receiving more load than this. Okay, that is fine. Based, just for the sake of this video, I don't want video to like take much time, because when video will take longer, most people get tired of watching it. So I will not explain more again. But in the course video, which I said we have already had, I explained more in details and explained other also other scenarios that you can consider. So if you want to have more in depth of more this for this video, I would advise you get the course video. Okay, that is fine. So with this now, I'll just say okay, but let us see our bars first. Now, based on this, eccentric footing are meant to also have a top bar. So we make sure you add a top bar to like this. Okay, that is fine. And also include these bulbs. Make sure you do this. Okay. Now, I will not say okay. Now, even if we have said okay now, correct, and went down, and then we come to our design status here, you can see that everything now appears okay. It's green, yes, but as it's green, does it mean that it is okay? No, it will fail. If you go to site, it will fail. Because why will it fail? Based on the thumb rule, the eccentricity is already more than b all over 6, so it will fail. Now, because now it will fail because there is an overburden pressure happening here. Overburden, sorry, not overburden. Turning moment or force happening here, which is causing what? An uplift and uneven soil within this region. So that is why it will fail. So how do we now do? You now have to do what? Apply your engineering experience, but now inserting what? Inserting a strap beam. Okay. So right now we are not going to model a strap beam on this footing here. So to model a strap footing, I'll go out from this my design interface now, and then I would like to make my screen dual, to have a dual screen like this to show this and also this here. So correct now that we now have this now, the next thing we do is now model the strap footing here, and that takes us now to the modeling tab here. And then under the modeling tab now, note that 2026 is the version that only has a sub basement beam. You cannot use a normal beam to design for this, or a foundation beam. If you use a foundation beam, then it is no longer acting as a strap beam. It is now acting as a foundation beam. But the strap beam concept is different from a foundation beam. So I will use this beam now for this design. So in that course now, the next thing to do again is to now give my strap beam section property. I will be using 225 by 225 because the column here is 225 by what? 225, as you can see the column size here, width. Then for the depth now, knowing that when it comes to section, you have to assume first. After your design, then you will see if it is okay or not. For my depth, I will be using 450. All right, for my depth, knowing that, as you can see, this footing depth here is 300 and this footing depth here is 400. So let me use 450 for that. Okay, that is fine. Now, when you have done that now, the next thing now we'll do now is to now come now and then insert your strap footing. Now, note, okay, I'll insert my strap footing now, and now come again here and then do this. So once I've done this now, you can now see how our strap footing now appears here. As you can see our strap footing now, you can see how it appears here. Correct. Now, this is our strap footing now that is appearing here. Let me just put it like this. That is appearing here now. You can see how it appears. Correct. Now, basically, this, if it is too far, as you can see from the footing, it becomes a tie beam. And if it is too far again, it becomes a plain beam. So you have to make sure, and if it is too low, if it is directly at the base, let me say directly the same level with this footing, it then becomes a foundation beam. So how do you model it to make sure that it is serving the purpose of a strap beam? That is the question there now. So how do you do that? First thing to do is to locate and look at your foundation depth, which you have here on your foundation building height here. You can see my foundation depth here is 1000, although this can change at site. You understand? This is just my assumption for this design. It always changes at site based on the topography of the site or of the land. Okay, that is fine. So now that I know that it is 1000, which I'm using for that, which all other footing here are being generalized on. Okay, that is fine. So I will then come now and then click on this place here, and then right click here and I'll come now and then click on this place here that says property. Okay, and I will come here now that says 3D, and then I will come here and then put in the value minus 3. First of all, if I put minus 550, based on that this beam is 450, I put minus 550 here and also minus 550 here. See what will happen. I click on this. You will see that each of the footing, then this beam now will now be at directly on the ground with the can you see that with the same level of the footing, which means that this footing, this strap beam now is now resting directly on the soil. And when a beam is resting directly or has direct contact with the soil, it is being supported now by the soil. It is now acting as a foundation beam. So now in that case, this is no longer being treated as a strap beam, which is what meant to treat. So just to avoid that from happening, the general principle of a strap beam is for this beam to go off from the soil, that it should not have direct contact with the soil. Let me do something here just to have a clearer view of what I'm doing right now. I'll click on this, click on this, click on this, click on this, and then click on this. And I'll come down and say show only selected. Okay, that is fine. So now we have a clearer view of this now. Okay, I can also go and hide my grid lines just to have a clearer view again for this. Now on hiding my grid lines now, you can now see what we have. We now have this fully. Can you see that? Correct. Now when this happens like this, I can choose to make it like this. That's fine. So when this happens like this now, you can now see what happens here. This beam now is now at the same level with the footing, which is this beam is resting on the soil, having direct contact with the soil. And when this happens, it is now acting as a foundation beam and no longer the principle of a strap beam. So what do? I'll click on this, right click here, properties, and lift it up. The minimum that you can allow your beam here not to rest on the ground, you can take from 100 and above. So in this case, I'll come back here. Okay, I'll come back here and I'll put my value to be what, 300. Sorry, 300, and then also here 300. On the course video, I explained more about this on how to do because it's very, very long. But I'll put here 300 and I'll say okay. Now on doing that now, I'll wait for that to finish up. You can now see that it is now being lifted. Okay, it is now being lifted from the from this thing here. So this is how a strap beam is meant to be, so that it will not have any contact with the soil to prevent it from acting as a foundation beam. Okay, that is fine. So with this now, it is now acting as a transfer member, which is now called a strap beam. So it is now acting as a transfer member, transferring the moment from this column and from this footing onto this place, and also at the same time balancing. As you can see, it also has contact with this footing, balancing, causing a balance to this footing, not to have an uplift or what, overturning. Okay, that is fine. Now most people I have seen in site construction, most people do major mistakes, and what they do, they tend to design a different concept altogether. I don't know what they call it. That cannot be anything way or near or closer to a strap beam. Let me show you for that. I saw someone designing this, all right, for an eccentric footing, and I saw a video. It was a site construction that has this kind of concept. As you can see, this is the site construction here. As you can see that, you can see it here, right? And I saw many people were praising the guy in terms of comments. Okay, someone asked, can you explain what you're doing here right now? Because from what I'm seeing here, the purpose of this of a strap beam is meant to do what? Meant to transfer moment to the next interior footing, all right, and also to transfer everything, and also to cause what? And also to cause a counterweight. But this, as you can see here, this is like a cantilever beam. You understand? And this is not transferring any load to anywhere. It's not transferring any moment to any footing. It is just on itself. Now it is even adding more self weight to this footing. So this is a blunder. Basically it's a blunder. And also remember, I like always say, most of our designs are standing by the grace of God. You understand? I'm telling the truth, because if you see what people do at site, it's you cannot really explain it. You understand? Structurally. So this can never and cannot be a strap beam. You understand? Never you practice this. This is a no. Never do this. Okay, that is fine. So the real engineering way is to model it directly as a strap beam. So at this place now, using this, what you're doing is that you have stabilized the like the soil pressure that was triangular around this footing, from being triangular as it was like this before, all right, to now being what? To now being a uniform. Okay, to now be uniform, which you can see something like this. It is now called a uniform, which you now have. So the soil now becomes uniform. Okay, the soil pressure now becomes uniform on this footing. Okay, that is fine. So in this course now, once you have modeled it again now, what is the next thing now to do? The first thing to do is to model it correctly, right? Now once you have modeled it correctly, it is now it now moves to design. Now note that this footing here must be doubly reinforced. It's a must. Must be doubly reinforced. Why this footing? You can choose not to apply double reinforced. If you apply it, maybe you're just wasting money. Single reinforced can and is okay for this footing. But this is a must that it must be doubly reinforced. As you can see that we apply the double reinforcement here for this footing. We have applied a top bar. If I open this now here in this place, you can see that we have a top bar. As you can see that here, we have a top bar and a bottom bar, which you can see that this is the bottom bar and this is the top bar. If I also take you here to this place here, this is a bottom bar and this is a top bar. Correct? That is fine. So I'll then say okay again. So when you have done this now, the next thing again you do now is now design for this strap beam, because this strap beam has not yet been designed for. If I open the design, my review design tab here, you can see that the only thing that is being designed for now is just this footing, this column, and this column is what is being designed for. Okay, that is fine. Then the next thing you do right now is not design for this strap beam, because right now everything now looks green except this strap beam. Now how do you design for this strap beam? That is where FE analysis comes into play, because anything that has to do with foundation apart from pad footing or pad foundation design, every other type of foundation design, it is advisable to use an FE finite element analysis, which you are seeing here. Okay, that is fine. So you have to make use of that. Okay, that is fine. So we are going to use this FE finite analysis here. Okay, that is fine. And you can also see that before this time, we already have done our FE analysis design, which I did on the course video and showed the principle of why we do that. So right now we are only moving on the FE foundation analysis, knowing that you already know the principle of FE floor analysis. Okay, that is fine. But if you don't know, you can get the course video and apply for that. So on this now, we will then move to now design for this strap beam. And how do you design a strap beam? The first thing to do is to first of all run the FE foundation analysis first. So I'll click on this now and then let's run analysis. Now I also assume that you already know the principle of doing all this. Now if you're using 2026, you must include this sub, basement, slab, wall, and beam. Okay, because what we use here to model this and what you can only use to model this is a sub basement beam. Okay, that is fine. You cannot use a ground beam to model this. It will not function as a strap beam, and you cannot also use like a normal beam to use elevation and bring it down. That will not work. It will not give an issue. So using this now, you must check this, because normally it is not like this. You must check this, and when you check this, check all these things you are seeing. Make sure you check this power solver. Okay, it helps a lot. Then you then come now and then click on what FE mesh analysis here. and then wait for that to finish up. So you wait for the analysis now to now run, and then let us hold on for that to finish up. Now, while you wait for it to finish up, you can use this month of April to enroll for Eccentric mentorship. Get our product that you feel has been expensive over the years, like from January to now, because month of April we are giving out 50% discount based on Eccentric anniversary week, which will begin on the 22nd of this month. But currently our anniversary discount has already been added, which will fully be added fully by this weekend for other products. But most of the products that you will see a fire flame added to it has already been counting for the 50% discount annual, and it will end on the month of April 30th. Okay, that is fine. So I will now come and do a click on what OK here. Now on OK now, I will then just click on what close here. Now once I've done that now, that means that we have now run what? Analyze this footing by transferring most of the moment now into this beam, and then into this trap beam, and then we will now come here. We then come to this design now, and then click on foundation beam. So I'll click on this design now to design for the foundation beam. Since we have only one beam here, that's what we're going to see here. But on the course video, where we modeled all other beams, we modeled all other beams on the structure which we are seeing before, which you saw before. We modeled all other beams for, let me just say show all. We modeled all other beams for this structure which you are seeing here along this line. Okay, correct. So, but for the sake of time, you can see that we are already 46 minutes ahead for this, so, and that takes time already. So I'll just show this back again right now. Show this again. Show. Select that, that's fine. So I will show this again right now. Now we now have to do a design for this. So I'll come here now and then click on this. So coming here now, I'll then come back here and then click on what? Batch mode design. Now before we do batch mode, we have to do some settings first. So come here and then click on the settings here. Make sure you are on the foundation area here. Come to beam. Sorry, not detailing. Come to design parameters here, and then make sure you are on the foundation beam here. And on this place, make sure that this is 50-50-50 if you're using BS or Eurocode. And then that is all. That's all. Although there's some things you like it, but I think I explained that much on the design. But I believe you already know these ones on the course video. So once you've done your full settings in that place, you then come here and then click on what? Batch design. And then make sure you click on this one here, this option here, click on what? Calculate. So once you've done that now, wait for it to finish up and then click on what? Close. You can now see that our beam now is now designed for. Now once you design a beam, you can see that if I say okay now, if I click on then close now, and then come back here, click on here, right click here, and then say update still, you see that this beam now would now be designed for it to show green. Now even if it has shown green, let us now look at the reinforcement that was used to design for that beam. Okay, that is fine. So I'll come back here now and then double click on this place here, and it will now display the interactive design for that beam. Although this will show, just ignore that and then say okay. And then once that displays now, we then move on to the next part, which is now selecting our, yeah, now you can now see that it is showing this. I don't like all these ones, so I'll just first of all remove this bar first. Okay, and the minimum bar you can use here is 16 based on standard of our Eurocode or BS code. So I'll come now again, as it's filling, I'll come back in, and then you can see that based on it is countering tension, right? Tension, that's uplift. The top bar are always higher, okay, are always higher than the bottom bar. Now ignore these things. I've already explained this on almost all our videos. These are for spacings. As long as the value is more than 20, all right, 20, ignore it, because that value is what the size of what our aggregate, okay, chippings, okay. So ignore that, and then I'll come here now. Now you can see that this is 3 and this is 2. Basically this is okay, but you can see that the area here is small. But for me, I like to have my value here to be more than 75. Even if this is okay, it is showing green, it is okay, but I like to have it at least 75. So I'll come down and then do what? Add it to be 3. Okay, that is fine. But you can leave it as 2. It is perfectly okay. Okay, that is fine. But your top moments are always higher than the bottom based on what strap beam design. Okay, that is fine. So I can leave it this way. It's okay. I'll then come and do what? Say okay here. So I'll now come and do what? Click on what? Close. So with this now, we have designed this trap beam and have also applied our engineering justification. Now note that had it been this beam was, you used a foundation beam which you can see here to model for that beam. what happened is that the soil effect will be on this beam, and it will no longer be designed as a transfer member, okay, no longer as a transfer beam, but rather as a foundation beam, okay, which you have changed the concept of a strap beam to a foundation beam. Okay, that is fine. So you can now, I will now come back now and then click on this. So you have now seen how we are able to design for a strap beam. Okay, that is fine. So if this video finds you well, please share to other younger engineers. If you're a student, you can share this video to your WhatsApp group so that other engineers too can learn. Please try to spread knowledge and don't just keep it for yourself. Okay, that is fine. And then we look out for the next. Now, our next video will be coming up on what do you think we should be on our next video? Although I already have mine, but let me know. You can drop it on the comment section, and then we will pick the like the first top 5 and then focus on that video for next month, which is the month of May. Okay, that is fine. So thank you so much and God bless you. Please give this video a thumbs up and then bye for now. Bye then, and then see you on our next video. Take care.